Hello students, welcome to Legacy IAS Academy. So in today's video, we are going to discuss about the Nobel Prize in Chemistry that has been awarded to three scientists in year 2023. They have done their work in the field of quantum dots. So we'll try to understand that what is the contribution they have made in the field of chemistry and overall science, and what is the concept or the strange world of quantum dots. So first of all, if you try to understand the context in which obviously we are discussing today's issue. So very recently, the Nobel Committee has awarded for year 2023 Nobel Prize for three accomplished scientists. These are Mongi Bawendi, Louis Bruce and Alexei Akimov. They have been awarded for the discovery and synthesis of quantum dots. These smallest components of nanotechnology basically are able to spread their light from television and LED lamps and can also guide surgeons when they remove tumor tissues, among many other things. That means what basically we are trying to say, that the synthesis of quantum dots has a wide ranging applications which include the field of medical sciences, which include the field of technologies, or we can say televisions and LEDs. That includes also synthesis of cure for diseases such as cancer and all. So what exactly did these three scientists have discovered, and why is it important? Let us try to understand this in more detail. So let us first try to understand what is quantum dots, because the synthesis of this is what has caused the Nobel Committee to award the Nobel Prize in this year. So the properties of any elements, if we try to understand, basically if you look at any element, the property of that element is determined by how many electrons it has. That means that basically determines its atomic number, atomic weight and all, and that largely determines the characteristics. So that only is applicable when the element is in its normal size or a larger size. However, when we reduce the size of the matter to a very smaller scale, that means we can say at somewhere at the nanoscale level, at that particular dimensions, what happens? The properties of this element then do not depend on the number of electrons, rather than they start to depend on the size of the matter. And the smaller a particle becomes, the more its electrons are being squeezed into a tighter space, and that is believed to affect the properties, all kind of properties, physical properties and chemical properties of that matter. And such particles, where they are being reduced to a very small scale, nanoscale, and then the size of these elements, when it start to determine the behavior of these elements, then such elements, such particles are what we can call as quantum dots. In short, again, if we try to revise, any particle, any element, when the characteristic of these elements are being determined by the size of this element, such elements or particles can be considered or called as quantum dots, and synthesis of this is the reason behind the award of Nobel Prize in Chemistry for this particular year. So basically, this information or this understanding was available in theory among scientists for a very long period of time. That means scientists had known for long that such particles could exist. But here the three Nobel laureates have played a very important role, because through their work that has spanned over generations or decades, we can say, they have been able to succeed in creating quantum dots of high quality, which can be put to a practical use. So let us try to understand the science behind the quantum dots. Now, if you try to understand the element property, as we have discussed, it is usually determined by the number of electrons in its atom and the distribution of these electrons around the nucleus. That means, in a layman term, we will try to understand that every piece of a pure element, no matter which element we are talking about, whether it is gold, whether it is silver, whether it is tungsten, what happens? Exactly, it exhibits the same properties regardless of this size. That means, if you look at this particular image, we have the gold pieces that is as small as 1 gram in size, and it is as large as 100 gram in size. Variation is observed in between. So no matter which of these gold particle or gold matter you take into your hand, or gold matter you use for certain purposes, they will exhibit similar kind of properties. Similarly, it goes for the silver as well. All the different size of silver will have the same properties. On the other hand, you will see the differences between the gold particles and the silver particles, obviously. But it was in year 1980, the new discovery was made, where it was seen that if the particles become very small in size, that means when they are reduced to a nanoscale range, they used to behave slightly differently from the larger particles of the same elements. That means all these particles of gold will have same characteristics, same behavior. But you take this gold particle, reduce it to its nanoscale, then its behavior will be very, very different from the behavior of all these larger gold particles. And that was something that was observed in 1980 in the Soviet Union by the Ekimov. However, that time Soviet Union was basically surrounded by what we can say a political iron curtain, and that is why this discovery by Ekimov was not known to other part of the world. And thus, it was Ekimov who understood that a nanoparticle, which ranges in the size of 1 to 100 billionth of a meter of gold, displayed properties different in some respect from the larger particles of the gold. And the biggest particle, if we talk about the one example of how they differ from each other, we can see this diagram also, that depending on the size of gold particles, the reflection or absorption of light varies also. For example, when the gold particles is larger in number, we can see, when we talk about this, we are talking about copper chloride. So Ekimov was working on the copper chloride, and Ekimov observed that depending on the size of copper chloride particles, if the size are higher or bigger in extent, in that case they are largely reflecting yellow to reddish kind of light. On the other hand, when the size of copper chloride particles is continuously being reduced and when it is brought to a nanoscale, now we can say it is basically reflecting in the spectrum of bluish to greenish. So this differences is largely because of reduction in size to nanoscale. That was something that was observed by the Ekimov. Now let us try to understand what has been the contribution of these three scientists. So as we discussed, Ekimov, working that time in the Soviet Union, used copper chloride to color glasses in different heating and cooling scenarios. Interestingly, turned out the glass light absorption was affected by the size of particle, and thus this was something that was termed as size dependent quantum effect. Similarly, working separately in the laboratories of the United States, the another Nobel laureate, he was doing chemical reactions using the solar energy, and he was working with cadmium sulfide. And then while working with cadmium sulfide, he observed that he can capture light and drive reactions. And while the larger particles absorb light at the same wavelength as cadmium sulfide generally does, the smaller particles of cadmium sulfide had an absorption that shifted towards blue. And thus it means that the physical characteristic of cadmium sulfide particles, which are at a nanoscale, differs from the physical characteristic of the large size cadmium sulfide. And that means the physical characteristics vary. They extrapolated that all other kind of characteristics of this nano sized cadmium sulfide particles will be very, very different from the larger size cadmium sulfide particles. Similarly, this was something that was understood by Bruce, and working upon the Bruce method of creating tiny particles, it was the third Nobel laureate of this year. He improved upon the Bruce's method of creating tiny particles by using different solvents, different temperatures, and different method, different technique, and thus he was able to create nanocrystals that were almost perfect. Obviously, the scientist is Bawendi. So Bawendi was able to improve upon the Bruce's method, created or produced almost perfect nanocrystals, giving rise to distinct quantum effects that can be put to the practical application. Now, if you look at what is the practical applications that these quantum dots can have. So first of all, it can have very huge implications in the area of computer and television screens. The luminous properties of quantum dots have been utilized, and they are basically also are based in, you might have heard about QLED TV or QLED technology, where Q stands for the quantum dots. Recently, LG was the first brand that came up with the QLED technology, QLED TV, and now it is believed that Samsung, Sony and other brands are also trying to create their own QLED screens. The other application we can see in the LED lamps, where the cold light of diodes can be adjusted by using the quantum technology, quantum dots. Light can then become as energizing as daylight or as calming as the warm glow from a dimmed bulb. That means from a single bulb, you will be able to produce different intensity of light if the QLED technology is being used there. Third application, which is again most important application of quantum dots, quantum technology we can see, is in the area of biochemistry and medicine. And here it is believed that biochemists can attach the quantum dots to biomolecules to map the cells and organs of the individual. Also, doctors have already begun investigating the potential use of quantum dots to track tumor tissues in the body. And also chemists instead use the catalytic properties of quantum dots to drive chemical reactions. So already these things are something where we can already see the practical implications of the work of the three Nobel laureates. Apart from that, quantum dots application can also be seen in the case of bioimaging, biosensing, immunoassays, drug delivery, detection of genetic diseases, as well as many clinical applications, the examples of few which we have just seen. Now, before wrapping up this video, let us try to understand in briefly about the three Nobel laureates. So, first of all, as we have discussed about Alexei Ekimov, who is credited with first of all recognizing the change in behavior of the smaller sized particles. So, he is currently working in nanocrystals technology incorporation in USA, and he was born in 1945 in the former USSR. He got his PhD in 1974 from the Law of Physical Technological Institute in St. Petersburg, Russia, and formerly he was chief scientist at nanocrystals technology, New York, United States of America. If we talk about the second scientist, that is Louis Brew, he was born in year 1943 in the Cleveland of United States of America. He got his PhD in 1969 from Columbia University, New York, and currently he is working or serving as a professor in the same university. On the other hand, if we talk about the Bawendi, he was born in 1961 in the Paris and grew up in France, Tunisia, and the United States. He got his PhD in 1988 from the University of Chicago, that is in the United States of America, and he is a professor at the MIT, that is Massachusetts Institute of Technology in the United States of America. So that is all about this particular video. I hope you understood the rationale behind the award of the Nobel Prize in Chemistry in the year 2023. That is all for this video. Thank you very much.